So I am Dr. Pragya, professor here in the Department of Community Medicine. And along with me, there is Dr. Shamshad, who is again associate professor in the same department. And you will meet mentors and the facilitators in your breakout room. So how we will flow, or we have planned this session. So we will start with the since the session is on the agreement analysis. So we'll start with the Cohen kappa, then we'll go to the weighted kappa, then we'll show you the uses and how to give the commands for Fleece kappa, and then we'll come to the Krippendorf alpha. In this whole 3-hour session, we have got 3 breakout room activities, one on Cohen kappa, the second on the weighted kappa, and the third on the Fleece kappa. And the Krippendorf alpha we will keep covering in between. The next is to, like, you have got the mentors, but depending on the participants, if there are more breakout room, and in any breakout room, if there is no mentor, then you people can assign a facilitator. You can choose from your group and you can practice during the breakout room. The timing of each breakout room is 15 minutes, and it is desirable that all of you please share your screen and show the commands which we are telling you right now. And we will keep moving from one breakout room to the other breakout room in between, just to see whether you people are practicing or not. So starting with the Cohen kappa. So we are just covering some basic concepts of this agreement analysis. So let's say if 2 doctors they are diagnosing 100 X-rays for tuberculosis, and in that, if you see, they have written, like, few of them has said yes. So there is a Dr. B and there's a Dr. A. So here it will be Dr. A. By mistake, it is written as B. So Dr. A has read this 50 X-ray and diagnosed this 100, let's say 100 X-ray into 50 and 10, and then again said negative on these 40. So he has said 60 as yes and 40 as no. Similarly, Dr. B, if you see, he has said positive for 55 and again negative for 45. So if I have to calculate just the simple agreement, what is the total number of yes where they have agreed, or the total number of no where they have agreed? So if you see this 2 by 2 table, this on 50, because the 50, Dr. A has said these 50 X-rays as positive, and Dr. B has also said this 50 X-rays as positive. So the agreement on positive diagnosis is 50, and again on agreement on negative diagnosis is again 35. Why? Because 35 is the same number. Dr. B is also saying that these are the negative X-ray, and Dr. A is also saying that these are the negative X-ray. So what will be the total agreement? If I just have to calculate the total agreement, how I will do? I will just total these two numbers. So 50 plus 85, and the total agreement is 85%. But again, if I have to come to know, like, whether this agreement is by chance or this agreement is a true agreement, in that case, we need this kappa statistics. So what is this kappa statistics? Basically, this kappa is it's just removes the chance agreement. So what is the chance agreement? Chance agreement is like, even if the raters are not very skilled, and if they are just doing the random guessing or random, not going by any parameter, then what is the probability that it will be correct, or there will be agreement? So when there are two raters, even if they are doing something by chance, so what will be the level of this agreement? And this agreement is real, or it's not a coincidence. For that, we need this kappa. So this now, if you go to this Cohen kappa, so Cohen kappa is a statistical measure where we show the agreement between the two raters. What is the true agreement? Possible true agreement, like if you remove the chance factor. So this is the unweighted Cohen kappa, because there is a weighted Cohen kappa also. So what is this unweighted Cohen kappa? So in the unweighted Cohen kappa, generally it is applied when there are two raters. The second important part of this Cohen kappa is like these are the rates or whatever the variable which we have selected, that is a categorical variable. Categorical, especially the nominal variable. And you know what is a nominal variable? Like let's say gender. There's a male and there's a female. Or let's say if I am diagnosing like blood grouping, blood group A, B, ABO, and O, then again, this is a nominal where if you change the order, that does not matter. So in case of a Cohen kappa, the agreement should be on a categorical scale. Coming to this rater, this thing, whatever will be the number of categories, these categories should be same for both the two raters. That means if I am labeling or I am reading X-ray, classifying it as yes and no, the second person or the second rater should also do the same thing as yes and no. Like he should not be adding a third category. That means the 2 by 2 table or the 3 by 3 table, that should be symmetrical. We'll see that in the example, but this is basically the inter-rater agreement when there are two raters. For example, again, we have seen one example of a tuberculosis. Let's say if there are two family physicians and there are 50 patients. So if both the family physician rate these patients as whether to refer or not to refer. In this case, the variable is a categorical variable and both the rater, they are rating those patients on two categories. So it will be a symmetrical table of 2 by 2. Coming to the uses of this Cohen kappa. So Cohen kappa is used in a variety of cases. We will see a lot of example when we can use. So basically, whenever you are measuring the agreement between two raters, then we use the Cohen kappa. Some variant can be if you are using Cohen kappa to see the agreement between one, a very experienced rater, and the second, a less experienced rater. Because in training, we see also that one person, if a very good professor, he is reading X-ray very nicely, but he's training the residents. So if we see the agreement between the resident and that professor, so that professor will be a trained person and the resident will be a less experienced one. So if the agreement is good, then we can say that yes, definitely the now residents can also read X-ray very well. So either the two rater will be on the same level or it can be one very experienced rater and the other a less experienced one. And again, it is again useful when even if you have got two measurement scale or the two measurements instrument. So if you have got two measurement instrument, then also